Hello, in this presentation I will introduce you to VisualARQ, an architectural design software that adds flexible BIM features to Rhino. I will show you an overview of its main capabilities. What is VisualARQ for? I would like to summarize the three main functions of the program. First of all, VisualARQ provides tools to produce BIM models in Rhino. That means that you can turn any Rhino geometry into an informed object, annotate it with data, and report quantity takeoffs. Secondly, VisualARQ adds tools to generate plan views, elevations, and section views from any 3D model. These views can be produced as 2D drawings in the model space, or as real-time model views that can be printed directly to vector output. Finally, VisualARQ provides the option to exchange Rhino models with other AEC software through the IFC file format. So I'd like to highlight the VisualARQ's key features according to these three different topics: 3D modeling, 2D documentation, and IFC file exchange. Starting with 3D modeling features, VisualARQ provides a set of architectural objects that are parametric, associative, and have a simultaneous 2D and 3D representation. You can edit them easily through parameters and control points, and they are managed through types and styles that define their dimensions and attributes. These objects have their own parametric features, but they are fully customizable because they can be also created from Grasshopper definitions. These are called Grasshopper styles. You can see how it works in 3 steps. You have a Grasshopper definition that has a list of parameters that define the shape and features of a revolving door. On the other hand, there are different geometry params that collect the different parts of this object. Then you can open the Door Styles dialog to create a new style using this definition. So you open the Grasshopper file, and you get the list of components and parameters defined in the Grasshopper file. You decide how you want to edit them, and the object becomes a new door in the Styles library. Finally, you can just insert the door in the model, select it, and change its parameters from the Properties panel. At this point, no Grasshopper knowledge is required, although Grasshopper is running in the background. That means that people who don't know Grasshopper can use objects that others have developed. That way you can have multiple parametric objects with different dimensions in the same document, all driven by the same Grasshopper file. In Food for Rhino, there is a section where you can find VisualARQ object styles created with Grasshopper. I encourage you to share yours as well with the community. One of the main features that helps streamline the architectural design process in Rhino is the Level Manager. This panel lets you create levels and work at different elevations. You can show and hide levels easily, switch the construction plane very quickly, and align views to levels ready for working and printing. There is also a section manager that lets you show the model in section by switching from different section lines. These are different than Rhino clipping planes, because VisualARQ sections can be jogged and show the section attributes on the 3D geometry. There are also tools to align views to sections for working and printing. One important feature related to the production of 2D drawings is the hidden display mode that VisualARQ adds to Rhino. As you may know, when you show the model in shaded display, for example, you can only print it to raster output. Otherwise, you see all the edges and isocurves that should be hidden. But if you use the hidden display mode, you can print the model in plan view, section view, or in 3D directly to vector output and get a 2D quality PDF result. If applied to architectural projects, you can see the model from one specific level, show it in plan view in real time, and produce a 2D drawing in vector output. And same goes for section views. You just need to make sure you use the hidden display mode, set the view in a page layout, and print it to vector output. Another way to produce 2D drawings with VisualARQ is by using the section and plan view objects. These are 2D drawings that are added into the model space, and they are linked with the 3D model, meaning changes in the 3D model will update the 2D views. Any piece of geometry, no matter if they are VisualARQ objects, Rhino poly surfaces, or meshes, can get section attributes such as the hatch pattern or line weight for the sectioned contour and area when they are displayed in plan and section views. Another powerful feature related to documentation is the option to produce quantity takeoffs. Any object, including blocks or Rhino geometry, can get data and be reported in VisualARQ tables, which can be exported to Excel afterwards. As I've mentioned before, VisualARQ provides the IFC translator that lets you import and export IFC files between Rhino and other programs. That way, some of the architectural objects exported to IFC are recognized as native objects in the program that reads the IFC file, and the other way around. The data stored in the geometry is also kept in IFC files. That way, you can assign a specific IFC type to any piece of geometry. In this example, a pole surface has been tagged as an IFC slab, and therefore it will be recognized as a slab or a floor in Revit or Archicad, for example, after being exported to IFC. In addition to the IFC tag, you can add custom information to objects, such as manufacturer, cost, material, or any other parameter, and this data will be exported to IFC as IFC properties. The concept of flexible BIM comes from the fact that since VisualARQ works on top of Rhino, it is possible to work with BIM objects with no limits of shape and design. But it is also related of how VisualARQ integrates with the Grasshopper. We have seen how VisualARQ allows creating custom parametric objects with the Grasshopper styles, but VisualARQ also integrates with the Grasshopper with the Grasshopper components, which let you automate workflows with VisualARQ objects and data in Grasshopper. So basically, there are components to create VisualARQ objects, like in this example, where a wall requires a path curve, and you can define more options like the wall height or the style. Then there are components to create new styles. So for a new wall style, we can determine the number of layers or the thickness of each one. Then there are components to deconstruct objects, so you can obtain the wall path curve, alignment, or height. And components to deconstruct the style, so you can access to the information of object styles. Since all these components live in the Grasshopper environment, they can interact with other Grasshopper add-ons that are used for multiple purposes. This is an example of how to use columns and slabs in a Grasshopper definition for a parametric structural system of a tower. And this other example, we can see how to automate the assignment of values for a specific property on a bunch of referenced columns by using only a few components. Another way to take advantage of the VisualARQ Grasshopper components is through the Grasshopper player, where you just need to open a Grasshopper definition which can generate VisualARQ objects and follow the steps in the command line to produce parametric results. The VisualARQ Grasshopper components are also used with the Run Inside Revit technology, which lets you run Rhino and VisualARQ as Revit plugins. In this example, there is a Rhino session running from Revit, where VisualARQ objects are modeled. A Grasshopper definition running in the background reads all the information of these VisualARQ objects and uses it to regenerate the equivalent object types and families in Revit. Now, I would like to show some user cases according to the different usages of VisualARQ. In the first group, mostly architects, I would include the people who use VisualARQ for 3D modeling, users who take advantage of VisualARQ parametric architectural objects that lets them raise a 3D model very quickly, apply changes easily, and get the 2D drawings very fast, like the case of this basilica in Salin, Croatia. This group includes projects where VisualARQ was used for producing 3D models for visualization purposes. And also people in historical BIM projects, like this lighthouse in Italy, where the architect was required to bring a point scan into a BIM model. VisualARQ was used to regenerate the 3D building from the point cloud, deliver BIM model, and produce the 2D drawings. Some people just use VisualARQ for producing 2D drawings of the project, like this example, completely created with Rhino geometry only. And this workflow also applies to projects of completely different type or scale, like this mailbox design. Finally, there are users who just use the IFC translator in order to exchange random models with other programs. VisualARQ is used to import IFC files and reach them by retrieving or assigning data to the geometry, such as IFC types or IFC properties, continue with the design in Rhino, and finally, export the model back to IFC to deliver BIM projects. Before finishing this presentation, I would like to mention that VisualARQ has commercial and educational licenses, which are perpetual with no maintenance cost. Educational licenses are available at a reduced price and are fully functional. You can download a 90-day evaluation version on the website. There is also VisualARQ API available, which we are expanding on demand. VisualARQ is available in several languages, it is very intuitive to learn, and there's plenty of learning material available on the VisualARQ website. We base the VisualARQ development on users' feedback, so don't hesitate to contact us with any suggestions or requests. I hope you enjoy VisualARQ.